and my group members are Ashish Bablani and Sahil Daryani. So today we are going to do exploratory data analysis on the wine quality data set. We have selected the wine quality data set for doing exploratory data analysis. So firstly I'll go through what is exploratory data analysis. Like it is an approach to analyze data sets to summarize their main characteristics, often with visual methods. When we are doing exploratory data analysis, we are going through the data, like what all is the data present into a data set and what all insights can be gathered through the visual representation, by drawing all the graphs, what all could be concluded through our analysis. That is just a basic of exploratory data analysis. So the purpose of the project was to preliminary exploration of the wine data with the goal of selecting right attributes for classifying wine into one of the quality categories. Like there would be several attributes, 12 to 14 attributes would be given. So based on that 14 attributes, we have to define whether the quality of the wine is poor, normal, or excellent. So it would be in three categories, whether the quality of the wine would be poor, normal, or excellent. So based on it, the packages that we have installed are why all these packages are included. Like tidyverse is the one of the important library for exploratory data analysis. Like for drawing all the graphs, we the main library that is used is tidyverse. And as we are doing exploratory data analysis, so data explorer library is also installed. GLMNET is a library package that is used for linear and similar models ka prediction. And GGALI is a library which is under tidyverse ka one of the library, that is ggplot2. Like it is an extended version of ggplot2, which is GGALI, which offers various other functions. Dplyr is one of the library that is included in tidyverse, which is very much important, and it offers a various range of functions like select, filter, group by. And Memisk is for basically for drawing that matrix in during the linear regression and multiple regression. Grid extra is used for drawing the grids, the representation of grids that is behind the graph. E101, caret, and reshape 2 are basically for classification and regression. Caret stand for classification and regression training. And E101 is for representation, and reshape 2 is also for representation of the graphs. So in the other step, like all the libraries have been included, and these are the and for imported the data set from the wine quality data set. Then for before performing all the exploratory data analysis, we have to know about what all is present in our data. So we have applied several functions like dim, which would return the dimensions, like how many records are present in our table, how many columns are there, and what all are the list of columns. And the another function that is under data explorer is plot missing. Like it would indicate how many missing values are present in our data. So in our database, like all the columns are whole occupied, like there is 0% missing data that is present onto it. And first step in data exploration is data validation and data quality. Like the str function is used to determine all the types of the columns that are present onto our database. We are having 13 columns in our database, so 13 variables are indicated. And summary of wine would be showing all the summary of all the data that is present. Like it would have a brief overview of what is the minimum in one of the column, what is the maximum, first quadrant, median, mean, and all. It would be for all the columns that are present onto it. And skimmer is just for skimming the library. Skimmer is the function that offers the skimming of the library. So when we apply the skim function, it would indicate, like it would give a brief overview of all the data, all the number of rows, columns that are present onto our database. And apart from it, like for plot for plot missing data percentage in each column. Here we have no missing data, so nothing has to be plotted. And after that we have to find out NA values, so there are no NA values in our data, and we have to remove the unnecessary data. That is remove one of the column, like the first column in our data set was ID. So for doing the exploratory data analysis, that column is not useful, so we have just erased out that we have just removed out that column from our database. And after that, we have plotted a graph find out to find out the correlation between each variables using scatter plot. Like the pairs function is used to represent the relationship between two variables in the graph. So here it has been indicated the when we have applied the pairs function on the vine, it would indicate the relationship of all the variables. And core plot and ggplot are all the functions are included in the tidyverse. So these all are functions that are included into our database. And after that we have added some new variables, like the variable quantity is of numeric type int, which is not convenient for the analysis. So first of all, like we have to change the type of the quality variables of the factor, and it is to determine data frame as a new variable, like quality dot factor we have included in it. And it can be categorized when the quality is greater than equal to 7, then it is good, and when the quality is less than equal to 4, then it is bad. And the medium we have categorized into 5 and 6. So we have applied all that into for the wine quality. Like we have applied a factor function which would be factorizing based on the quality of it. Like we have indicated three factors in it: good, bad, and medium. So factor function will have a factor function would categorize into provide a factor, would categorize all the values into a number of factors. So we have included three factors in it. And library.core plot, the EDA is performed into three categories, that is univariate analysis and plots, bivariate analysis and plots, and multivariate analysis and plots. For each variable in the data set, I plot its frequency histogram and box plot showing the range of perceived quality. So univariate is basically for each and individual variable. Like it would be indicating the relationship between all the variables individually. We have the variable name as acidity, fixed dot acidity, we have the column, so it would be indicating the graph, univariate graph would be showing only for the fixed acidity with respect to the wine quality data set. So as we are having univariate analysis, we have performed on 5 columns: fixed acidity, volatile acidity, citric acid, density, pH, and alcohol. And after that, after drawing all the plots using the q plot is just a function that is used for plotting. That the full form of it is quick plot. And scale x continuous, it would represent like what is the scale: 0, 0.1, 0.2. So it would be indicating the scale of it. And grid.arange function is included into the memisk function, that would be drawing all the grids of the graph together. And ncall would having a 2, ncall is equal to 2, means like we would be having two graphs in one of the columns. And we have drawn all the univariate analysis of all the variables. And after that, for normal distribution of frequency, the following variables are having have a normal or close to normal distribution: fixed acidity, volatile acidity, that we drawn previously. And distribution of variable citric acid frequency is not normal, but we will not transform this data for the purpose of analysis. Citric acid would be used for analysis, that is why we did not transform that data. So after that, we have plotted all the graphs for the univariate analysis. And after performing the univariate analysis, we in all those variables, the variables that were remaining, like the columns that were remaining, we came to know like they were not normal or close to normal distribution. The columns were residual sugar, chlorides, free sulfur dioxide, total sulfur dioxide, and sulfates. So we have drawn the histograms for it, and the histograms indicate that it was histograms indicate like it was right skewed a lot. So we have applied a log10 function for transforming that data, and after transforming that data through the log10 function.
Okay, so hello, I'm Sahil, and now we'll be continuing with bivariate analysis. In this section, we'll analyze the relationship between wine characteristics and its perceived quality. So here we have took two variables, x and y, and it is the bivariate analysis is similar to univariate analysis. The only difference is that there are two variables, x and y, and we'll perform the we'll find the relationship between x and y. Even the functions used here are totally same, only the difference is that we have given two arguments here, like for x is quality cat and y is alcohol, sulfates, citric acid, fixed acidity, and the y changes and not the x. And we have just put a box plot for the describing the relationship between them, and we have done two kinds of box plots, which one of it shows increasing quality of wine and the other one shows decreasing quality of wine. So in the increasing quality of wine, here we have used the variables which increase the quality of wine and then performed bivariate analysis on it, and then we have used box plot to show it. And then in the decreasing quality of wine, we have used the variables which decreases the quality of wine and used performed bivariate analysis on it and used box plot to show its difference. Later on, now we'll move to GG pairs.
Hello everyone, myself Ashish Bablani, and I am here to explain you the multivariate analysis and plots that we have implemented in this project. In the previous box plots, we have seen that increasing levels of both sulfates and alcohol increase the perceived quality of red wine. Now I have created a scatter plot to see whether a combination of these two may help distinguish between different quality levels. So here we have written a code for plotting the graph according to the quality with respect to count. The graph you are is displaying on the screen is now plotted because we have to differentiate between different quality factor. The small dot represents the low quality of the wine, and the highest dot in this graph represents the good quality of wine. The plot reveals a clear pattern showing most of orange and yellow dots that represent the high quality wine in the place where both alcohol and sulfates levels are high. There is also a visible range of violet dot in the middle of a plot, then the zone of the mostly green dots in the bottom left corner. This implies that such a combination of variables less distinguish between different levels of medium quality wines. The previous plots show there is a positive correlation between the variables of density and fixed acidity, so I create a scattered plot to see whether these two variables explain the quality changes well. So here is the graph for representing the quality different levels. It reveals some patterns in presented data. It is visible here that the majority of the green and violet dots are concentrated in the upper part, while the majority of orange dots are concentrated in the bottom part of the plot. Thus, this combination of variables may be useful to distinguish medium quality wine from high quality wine. Finally, I will analyze the influence of pH and sulfur dioxide on the quality of red wine. The left plot below shows the impact of pH total sulfur dioxide combination on quality. The zone of green dots, which is the medium quality wine, is immediately visible here. The variable total sulfur dioxide is highly correlated with the free sulfur dioxide, so I create the right plot to see whether adding another variable adds any value. It seems that the area of orange dots, which represents high quality wine, is more visible on the right plot, or while the green dots area is still clearly distinguished. The representation I have talked above is about these two graphs. One represents the pH with respect to total sulfur dioxide, and one represents total sulfur dioxide with respect to free sulfur dioxide. In here we see whether the concentration of which dots are where. So I like to conclude for these is majority of wines are normally normal quality, few are extremely pure while few are excellent. Since goal is to label wine as poor, normal or excellent, that's it.
Since goal is to label the wine quality data set into poor, normal, or excellent, so after performing all the exploratory data analysis, we have to just go ahead with the predictions of the model. So in this case, we have applied the linear regression. Linear regression is a machine learning algorithm based on the supervised learning. It performs a regression task like regression models the target prediction value, like based on the quality of the based on the quality indication of the wine. We have to indicate whether it is a we have to predict whether it is of the good quality or not. So in this we have divided our data set into two parts. First is the for training and other is for testing. Like the training, in the training we would be indicating we would be giving out the outputs of it, like if it is of if the quality of the wine is 7, then it would have a column into it which would indicate like it is of the good quality. So we have divided the data set into training and testing in training and testing into 70-30 ratio, and after that we have applied the linear regression model for predicting the quality onto it. And predict function will predict the quality of the wine. Predict function will predict the quality of the wine, and after performing we have to check whether how much is the error using the root mean square error method. So it indicates that there is only a little error. So model dot step function would find out the best model that is to be fitted for our data. And after applying that model, we have to summarize the output that is generated from that model. And we have to indicate predict the quality of the wine using that model. And after that we have, for the sake of representation, we have applied the tree model. Like it would draw a tree for displaying the quality of the wine. And random forest is one of the another algorithm that we have used for linear regression and classification. Random forest is an algorithm that is used for regression as well as classification. So based on it, we have given the model, the training and the testing data, and based on it, we have just drawn out some results, and we have indicated through the root mean square error the error that is in the prediction of the model. And through after applying all the models, like we have applied 4 models: linear regression, step, tree model and random forest. So this table would be indicating all the errors, like all the success ratio of all the algorithms. And in the end we have drawn up pairs of data frame that the pairs, like it would be indicating the relationship between all the models and the output that is generated through it, like whether the output is comparatively good or not. So in the end we have drawn the box plot of the alcohol with respect to alcohol with respect to quality, citric acid with respect to category, which would indicate all the variables alcohol and through after performing all the predictions, we came to know that alcohol and citric acid are the two characteristics that increase the perceived quality of wine the most. pH and volatile acidity, on the contrary, reduce the perceived quality of the most. More sophisticated prediction models should be able to provide, like we just had a we just had to perform the basics of machine learning algorithm. So that is why we used linear regression and random forest. But for maximizing the for minimizing the errors into a data set, there could be many other algorithms that we can use in a quality of the wine based on the other chemical characteristics. So these all were the functions that we have used. And This is the whole representation of the project and just a brief overview of what we have done in our project. So this is it.